Hello guys. So today we will be going over the presentation for my paper, which is Beyond Charts, Financial Prediction with Language Model and Time Series. So before jumping into the finer details, let's go over the agenda. So the agenda for this presentation is that I'll be going over some background in the abstract. Then I'll go introduce the exact problem I've solved in this paper. Then the literature review where I'll be discussing the literature, some of the literature which I went through, the most important ones. Then the research methodology I followed, then some discussion on the results and the conclusion and future work which I propose for this paper, and finally the references. So jumping into the abstract, so financial market volatility and the non-linear nature of the market is a challenging task in computational finance. Many researchers have been trying to solve that for years. This study compares ML models and deep learning models for S&P 500, also transformers, using financial time series data and a GPT-based approach. The pipeline which I did as part of this study included data cleaning, feature engineering, normalization, and systematic model training and validation. So the results which I got, the transform model achieved the best performance with RMSE of 0.15 and an R square of 0.977, as you can see here. Similarly, the GPT model also showed very high explanatory capability, but it was very unstable. The mean MAP, the mean absolute percentage error, is 81.62, which shows that it is having some limitations in financial forecasting. Mhm. So introduction. So let's go over some background. Financial technology has transformed, like fintech, basically has transformed financial markets with online trading platforms, HFT algorithms, and companies which are based around HFT, and AI influencing investor decision making and also forecasting. So the stock market involves millions of investors daily trading shares globally across like US, India, and other major markets like Europe. But market behavior remains highly volatile across geographical regions. One event somewhere else crashes the market in some other country. It's very unpredictable. So making prediction of the future has been a challenging risk and challenging task. So the traditional forecasting approaches such as fundamental analysis, technical analysis, we might all have heard about those when we talk about stock market, have been widely used to evaluate the performance of a company and the market movements. Like there are so many things, some of which like that come to my mind right away is the Bollinger thing in technical analysis and the 200-day moving average. These are some of the things which I can think of. Yet reliable prediction of the market behavior remains difficult, no matter how much markers or things you try to use. So the advances in technology and the ability of large financial data sets have created an opportunity to apply ML techniques as well as LLMs for this prediction. So ML is a bigger set, I would say. Particularly like DL models can identify complex patterns and hidden relations in the financial data is what motivated the study to explore, AI-based models beyond the traditional forecasting methods. Literature review. So these are some of the papers. Like as you can see, most of these papers are published in the last 5 years. So the methods, like the first paper used LSTM and LightGBM, which are some of the you know standard models used. The limitations of this work was like it had very limited comparison with other DL models. This one, Govindasamy, used RRE DLBSP. Again, it only focused on cryptocurrency, which is very narrowed, like it could have been overfit. Baloch et al. Used a couple of models like ARIMA, LSTM, CNNBI, LSTM. These are like, called as SOT, like state of the art models in terms of forecasting. So these DL models required high computational resources, what I found from this paper, and further optimization was all definitely possible. Soumya et al. Used by LSTMD and another very model, like standard model, but again this had the same limitation that it could have been overfit to only use Nifty 50 stocks. It's considered that an S&P 500 study is what the industry says for this. Similarly, Nagaraj used an ML based prediction model and it was very limited data set. And Gunasekaran and Matan Prasad used again ML models which were based on some stable data, and it was not done on volatile conditions. The data set they chose was a very, very stable time for. Yeah. Going to the research methodology. So for data collection, as it would been evident, I used the S&P 500 data set instead of going with Nifty. The design is not very, yeah, this is the image. I can probably do this, yeah. So for the data set, again, like I used 200k time order records over 5 years. Each record was had seven attributes: the open price, high price, low price, closed price, adjusted close price, volume, and stock ID. The paper discusses more about what adjusted close price is. The data set was limited to these records to ensure computational efficiency, which was one of the things which I marked in the previous papers. I didn't want to go too heavy on the computation. So for the data processing, like the data set was cleaned by deleting duplicate records, chronological ordering, missing in like the standard data processing formats which are followed across the industry. So the relevant features were retained and they were grouped by stock to maintain the temporal order. And yeah, for feature engineering, so for feature engineering, I used momentum features like RSI, MACD, and Bollinger Bands, which I discussed earlier. Target variables such as the next day closing price and the price direction, like direction as in will it go up, will it go down, they were defined as the end results for the models. Yeah. So continuing further about the research methodology, so feature scaling. So I standardized the data across all variables to control equally during ML training, like the model training, mainly because the open price should not have more weightage, closed price should not have more weightage. It should be linear and like they were normalized basically. So as you can see here, the standard scalar transforms were used and they were having mean of 0 and standard dev of 1, which improved the model stability and performance. Similarly, the data set was again, this is an industry standard, I would say, like splitting into 80-20. It's a very standard approach. So 80% was reserved for the training and 20% was used for validating or testing. So again, this also gives some confidence on the future data. Again, for this particular problem, I would say the confidence is not as high as other problems because, after all, as I said, this is a very volatile problem. So the proposed models, more details are in the paper. They were used like ARIMA, XGBoost, Transformer, and GPT-2. These four models were compared in my study. ARIMA is the baseline for the study. Like that's what we were targeting to beat using the other models. XGBoost captured the nonlinear relations between the financial features better. Transformer model learned the temporal dependencies better, and GPT model predicted future values using self-attention mechanism, which is what GPT does. Again, like the GPT model which I used for this study was conducted like last year. GPT-2 was very, it was almost free, so that's what I used for this. Pretty sure there are better GPT models now, and someone with like a company who wants to explore this problem, they can definitely go for something like a GPT-5. Evaluation parameters. So the parameters which were used were like MAE, RMSE, R square, MSE, and MAP, which is mean absolute percentage error, which I said earlier. These are considered standard for any forecasting model. So these were predicting prediction accuracy and error magnitudes. Like you can see that like R square is a good example for that, and lower error values and higher R square indicated a better forecasting performance is what was set as the baseline. So the results which I got. So these were the results which I got. R square for baseline was minus 1.6, which said like the baseline definitely could be, could have been tuned better. XGBoost turned out to be third. Transformer turned out to be second, and GPT-2 was the best model, which proved that using a large language model for this problem probably makes more sense. These are the plots. Again, you can go through this in the paper as well, like it's more evident in the paper. So as you can see, the predicted and the actual were pretty, I mean, this is the residual, which is like this is the predicted, and this is the predicted, and this is the actual. So yeah, I would say it was a decent experiment. Again, continuing the results and discussion. So these are some of the models. Like these are data which has been taken from other papers, and FFNN, LSTM, and RN LSTM is considered standard. And I have compared the results which I got with these. So this is where the thing is, like this is about Apple stock. If I'm not, yeah, this is about Apple stock, and you can see that I got a 95% confidence interval estimating a future price of about 171.93 based on a value of 163. Okay, yeah. So the comparison in the table 3 indicated that transformer model achieves the lowest prediction errors, and it outperformed Arima, XGBoost, and while GPT also performed well, but the mean absolute percentage was too high, which suggests that GPT kind of, I guess, you can say overfitted, despite the best efforts. So this is one to say equivalent to hallucination. Using transformer models for financial forecasting tasks may result into certain overfitting no matter how much you try. However, this problem could be better solved with the GPT-5. That brings me to the conclusion: future work. So the study sets the baseline that modern ML and deep learning models can perform better than the traditional stat models such as ARIMA. That's for sure. The transformer model achieved the most balanced results. GPT did better than the baseline transformer model, but had a very high MAP, which is not acceptable in production systems, I would say. Future work on this would focus on optimizing models to, further improve the computational efficiency and reduce the trainings and testing cost and even running cost. Like running the model on some stock, it should be cheaper, only then it makes sense. Other research would also use standard stat validation techniques so the models can be evaluated. So there are better, every passing year there is more work going on in stats as well, not just on the NLP and LM side. So there are new fundamental analysis methods as well, which we can compare our LLM approach with. So that's where the future research can go. And also we can explore with architectures of language models. Like one thing which I can think of is, like, I'm very interested and probably would be researching in the coming year would be using a small language model. SLMs are going like a good direction for the, what do you say, AI research. So SLM focusing only on stock prediction is something very fascinating, and this is where I could be going next. So yeah, these are the references which I have referred in my paper, and